Hello everyone, my name is Paris Gao and this is my ZID, PHYS1160. Perfect. So I'll start by describing our current understanding of galaxy formation and evolution. Galaxy formation and evolution is a complex process that began shortly after the Big Bang, with the first stars forming around 4 million years later. Galaxies are thought to form through the gravitational collapse of gas and dark matter, with dark matter playing a crucial role in shaping their structure. Over time, galaxies evolve through mergers, accretion of gas, and star formation. Now I'll move on to answering questions for 4 and 5. So for 4, talking about Comet and Hercules clusters. Comet clusters, there's the central region dominated by big, smooth, yellowish elliptical galaxies, and Hercules clusters. This cluster is spiral-rich and irregular in structure. Now in 4a, identify the color common in spiral. So there's blue arms, which is from hot, young, massive stars and star-forming regions. So pinkish red knots in the arms, which is ionized gas around newborn stars. Yellow and bright bulges, which is older stars in the central bulge. Now for B, compare the color seen. So elliptical galaxies typically appear smooth, featureless, yellow, red, orange overall. Little or no obvious blue patches, dust lanes, or clumpy structure. This color difference reflects their stellar population, so spirals clearly show ongoing star formations, while ellipticals are old, red stars with little current star formations. For C, which group of galaxies do you think are older in general? So the stellar population ellipticals are on average older than these in spirals. Because they're red in color, show that they're dominated by long-lived, low mass stars. Spirals still have plenty of gas in stars, so keep forming new blue stars. So D, compare the color and what this might tell you about age. So when you look closely at spirals, bulge, which is more yellow-red, smooth, equals older stellar population. For the disk arms, bluer and patchy equals younger stars and ongoing star formations. Now, when we look at 5a, comment on a recent formed young star. So we're looking at NGC 6745. So bright blue clumps and knots, especially along the distorted tail in the regions swept by the intruder galaxy. These blue clumps are massive, hot, short-lived stars, often bundled in superstar clusters. So this is evidence of ongoing star formation triggered by the collision. And what does this tell you? So in NGC 6745 illustrates that when galaxies interact, their gas clouds are compressed by tides and shocks, which trigger intense star formation. Shapes become disordered. Over time, interacting galaxies may merge into single, more massive galaxies. So now I'm going to comment on my results for question 6 and 7. So when we're looking at galaxy, we identify spiral, elliptical, irregulars. For question 6, I can see that they're mostly elliptical or regular, limited spirals. But for question 7, I see mostly spirals and irregular, a little elliptical. And now we're going to explain why and the similarities in question 8. So the similarities, all environments show that the basic Hubble types, which is spiral, ellipticals, irregulars, color still trace stellar population, blue equals young, red equals old. And the difference might be the environment effect. So cluster images have many red elliptical in dense cores, fewer spirals. While Hubble ultra deep field, you see the sample more general field and a wider range of red shifts. So you see more spirals and irregulars, especially at higher red shifts. Now we look at question 8a. So what implication does this have on our current understanding? So putting this together, it supports that environment matters. In dense cluster, spirals can be transformed into ellipticals via ram pressure, stripping, harassment, and mergers, quenching star formation and moving galaxies from blue cloud star forming to red sequence. 9, if we could take the Hubble ultra deep field in 10 billion years time, what difference might you see from now? So if we could re-image the same patch of sky 10 billion years from now, we can see many of separate small galaxies you see now would have merged into fewer larger systems. You'll likely see more ellipticals and obviously fewer irregular clumpy galaxies as those irregulars emerge and settle into stable systems. There will still be some star-forming spirals and irregulars, but the balance will be shift towards old passive galaxies compared to the original Hubble Ultra Deep Field. Lastly, what did you learn and what did I learn in this experiment? So firstly, color indicates star age and star formations. Blue clumpy equals to young stars and active formation. Red smooth equals to old stars and little current star formations. Morphology equals the environment. Clusters, dense cores dominated by ellipticals, spirals more common in outskirts. Field, high redshift deep fields equals to more spirals and irregulars. Thank you for listening.